Welcome to ICP DAS USA, Data Acquisitions Made Easy. This month's webinar is on vibration monitoring systems for predictive maintenance. And my name is Kathy Spiesi, and welcome to everybody who's attending. Our agenda this morning: vibration measurement and data acquisition, preventative maintenance, vibration sensors, vibration data acquisition equipment, networking and wireless equipment, vibration control and monitoring software applications. First, a little bit about ourselves. We are ICP DAS USA. Our parent company, ICP DAS, is headquartered in Hsinchu, Taiwan, and was established in 1993. ICP DAS USA was launched in 2001, and we are headquartered in Houston, Texas. Vibration measurement and data acquisition. We are all familiar with vibration. Vibration in cars as they go over bumpy roads, vibration of conveyor belts as they move parts through various processes in the creation of finished products. The vibration of motors and generators, robots, and machinery are all a part of any factory floor. What can vibration cause over time? It can cause a loosening of bolts, which can cause a misalignment of moving parts, which can cause a wearing down of parts like bearings and metal fatigue. It can cause metal fatigue, finally mechanical failure. When failure happens to critical machines, it can cause halt in production. In the case of my car, vibration caused a vital pin to shear, which caused a misalignment that would have caused premature wearing, but with the increased vibration, a check engine light came on, resulting in a trip to the mechanic, which saved the engine from much worse damage. If the problem had been left unchecked, I might have needed a whole new engine. In a factory, you would have ended up with production stoppages, causing financial loss. How do we protect our machinery from failing at an inopportune time? Data acquisition and predictive maintenance. Vibration measurement and data acquisition. We monitor the vibration of the system. We monitor the operating temperature of the components. We monitor current to see if there are any current increases, if there are any suspicious abnormalities. We create early warnings in our SCADA or HMI, or send an email or a text message so that maintenance can be scheduled at a convenient time so as not to interfere with production and avoid the risk of an untimely shutdown. The purpose of predictive maintenance is to reduce maintenance costs and increase product reliability. The difference between predictive maintenance and traditional preventative maintenance is that preventative maintenance is done on a schedule, and predictive maintenance uses data from vibration sensors, temperature sensors, and current measurements to predict if the parts of your machinery really need to be replaced. Preventative maintenance is done on a schedule, and that maintenance may not be needed at the time it's scheduled for. If your machine is only taken out of service when there are signs of an imminent problem, its available time to do useful work increases, and this can reduce maintenance costs by not doing unnecessarily routine tasks. You also have a better insight into the actual condition of the equipment, and this increases its lifespan. Predictive maintenance techniques are designed to determine if the condition of the in-service equipment in order to estimate and schedule the timing of maintenance, an approach that promises to reduce the cost of routine maintenance and increase the reliability of product production. Predictive maintenance and data analysis. Vibration analysis allows engineers to assess the condition of devices such as pumps and motors. By continuously gathering data on vibrations, engineers can predict when equipment needs maintenance. Vibration data is easy to gather and is very effective at identifying problems in equipment that use motors. Predictive maintenance and data analysis. The things that we can detect through data analysis of vibration, we can detect the unbalance of a motor, the state of its lubrication, misalignment of moving parts, cavitation, wear, bearing faults, lubrication failure, overheating, blade passage, vane passage, turbulence, pump recirculation, damaged rotor bars, loose stator windings, misalignment, operational problems, pipe deformation, resonance, rotating looseness, structural looseness, rotor eccentricity, rotor meshing, shaft eccentricity, bearing erosion, gear wear, friction, loose rotor bars, gear eccentricity, stator eccentricity, belt wear, pulley wear, overload, and more. Vibration sensors. There are different kinds of vibration sensors. Laser Doppler vibrometers are precision vibration sensors for no contact vibration measurement. The technology is based on the Doppler effect. The sensors sense the frequency shift of backscattered light from a moving surface, and these sensors are used in detecting torsional modes in a vehicle's drivetrain. They're used to inspect the status of bearings and motors. MEMS are used for contact applications. They are mounted on the machines that they're used to detect vibrations on. MEMS stands for Micro Electromechanical Systems, which are tiny devices that integrate electronic circuits, sensors, and moving parts onto a single chip. They're fabricated using semiconductor fabrication techniques. ICP DAS uses the MEMS technology in their vibration sensors. We also have the IP68 version, which is water and dust resistant. We also make IEPE, standing for Integral Electronics Piezoelectric Accelerometers. They are also used as vibration sensors. The IEPE Integral Electronic Piezoelectric Accelerometers are powered by a constant current, typically 2 milliamps to 20 milliamps. The output signal from the accelerometer is a voltage signal that is superimposed onto the same line on which the constant current is supplied. Coaxial cable is typically used between an accelerometer and signal conditioner or data acquisition system. The ISN 701 F15 L030 and L060 IPE accelerometers are designed for vibration measurement within a range of plus or minus 80 G and a frequency response from 0.5 Hz to 15 kHz. The ISN vibration sensor series is designed to accurately monitor machine aging and identify production equipment on the verge of failure, so as to avoid losses caused by equipment failure during the production process. The ISN 700 sensors can be connected to a monitoring system and upload real-time data. Engineers can analyze the vibration data remotely to find out which equipment has reduced production yield or even might have the possibility of downtime. This will bring a more stable manufacturing environment to the users. The ISN 700 provides IEPE and MEMS accelerometer measurement. It supports Modbus TCP and Modbus RTU protocol to read acceleration, velocity, displacement, and fast Fourier transforms or FFT spectrum values. From this table, you can see that if you have a medium-sized rigid machine of power from 15 to 300 kilowatts, and your measured vibration is greater than 4.5 millimeters per second, and you continue to operate the machine, that vibration is doing damage to the machine. On a machine like this one, once you exceed 2.8 millimeters per second, you should restrict your operations and schedule maintenance. You can see from the table that the more flexible a machine is, the better it tolerates vibration. And the larger a machine is, the better it tolerates vibration. Vibration data acquisition equipment. In this system, we have the ICP DAS ISN 711 MRTU vibration sensors, which communicates via Modbus RTU to our MDC 711, which is a data concentrator that logs vibration data. The MDC 711 allows up to 8 Modbus TCP masters to get the pull data, and it can pull data from multiple Modbus RTU slaves in addition to the vibration sensors. The computer running the Indusoft SCADA system with an HMI control panel that communicates via Modbus TCP to the data concentrator. Through the Indusoft project, we analyze and log data to a database. When the vibration exceeds the threshold that indicates the beginning of a problem, emails are sent and maintenance is scheduled. The system here uses the IEPE vibration sensor to monitor the bearings of a motor. The SG3227 is a 2-channel IEPE accelerator signal conditioning module. It has built-in 2 groups of dip switches which can be individually set for 2 channels to provide 2 milliamp, 4 milliamp, 6 milliamp, and 10 milliamp excitation currents to the accelerometer. And the built-in amplifier can provide anywhere from 1 to 10 to 100 times gain. The LED lights can clearly show the status of the sensor is normal, open circuit, or short circuit to avoid wiring errors. From the SG3227, we feed into the PET 7H16M, which is a high-speed data acquisition module. It includes 8 high-speed 16-bit single-ended analog inputs, 200 kilohertz sample and hold for 8 channels. It has 4-channel digital inputs and 4-channel digital outputs, and provides a programmable input range on all analog channels. You can choose plus or minus 5 volts and plus or minus 10 volts. And digital outputs can be configured with short circuit protection and overload protection. The counter values of the 4-channel low-speed digital input counters and the 1-channel high-speed counter are latched by ADC sampling times synchronously. And you can choose a number of different signal conditioning modules from the SG3000 series to measure input signals such as voltage, current, temperature, via thermocouples or RTDs, and provide 0 to 10 volts, 0 to 20 milliamps, 4 to 20 milliamp output signals. From the PET 7816M over to Ethernet, our data goes to a PC running a Viva Edge SCADA with control and monitoring screens. The ISN 700 series here is a vibration detection device that allows users to monitor the vibration status of their equipment by selecting either an external IEPE accelerometer or a built-in MEMS accelerometer depending on their needs. The modules support Modbus RTU, Modbus TCP protocols that can be used to read the computed eigenvalues and fast Fourier transform spectral values through Modbus commands for subsequent vibration data analysis. We have networking and wireless equipment. You can see we have various switches. The NS205 for hardwired Ethernet, and then we have the IWSN200U wireless data concentrator, which can connect to the ISN 711 MRTU devices, and those can measure vibration, and that data can go to an Indusoft or a Viva SCADA system or a WISE 5231M 4GEE wireless controller, which can handle if-then-else logic. Indusoft and Aviva Edge software can be used to create dashboards that provide actionable insights for decision makers. You can log and display your vibration trends on multiple pieces of equipment, and you can set it up to send emails or text messages to people that need to do maintenance. ICP DAS's free development software, HMI Works, can be used with a VPD series touch HMI device to design custom touchpad interfaces. HMI Works supports a range of graphic design tools and includes an expandable graphic library. It also supports the C language for IT professionals and ladder diagram for PLC users, enabling the creation of both visually appealing and functional touch interfaces quickly and efficiently. Our customer is a steel plant with a large array of complex equipment used in raw material transportation, steel making, and hot and cold rolling processes. During production, if any motor experiences a failure or breakdown, it will halt the entire production line, and the unfinished products must be discarded. This results in a reduced overall productivity, increased costs, and potential workplace hazards. To mitigate these risks, the customer aims to proactively monitor bearing vibrations and perform early maintenance on the equipment. To minimize losses and ensure the safety of the production line, the following explains how the client uses ICP DAS's equipment vibration monitoring and predictive maintenance solution to achieve real-time monitoring of process equipment vibrations. To identify potential issues early and plan for equipment maintenance or replacement, the customer is utilizing the ISN 701 F11 L030 IPE accelerometer and the AR400 accelerometer data logger to measure and store vibration data. He's using the VPD 130H Touch HMI device for real-time data display and threshold setting of vibration features. Additionally, the data is transmitted through Modbus TCP Ethernet to the ET7224 Ethernet I/O module. The ET7224 digital output channel connects to the ALM06WF MP3 alert module, which emits audible alarms during emergencies to alert personnel. The analog output channel of the ET7224 links to the existing on-site PLC, allowing it to convert the current back into vibration features. In this case, the ISN 701 F15 LO30 IEPE accelerometer captures vibration signals, and the AR400 accelerometer data logger calculates vibration features like peak-to-peak acceleration and RMS velocity. The AR400 converts these vibration features into corresponding current values. The ET7224 Ethernet I/O module receives the current values calculated by the AR400 accelerometer and data logger via the VPD. The VPD Series Touch HMI device features a high-resolution color touchscreen available in 3.5, 4.3, or 7 inches. It comes in with built-in communication interfaces, including RS-232, RS-485, and Ethernet PoE, and supports standard Modbus TCP and RTU protocols. This allows for seamless integration with various devices. It allows for the remote monitoring of connected I/O modules and visually displays data on its touchscreen. This feature provides clear and immediate insights into the on-site conditions for relevant personnel. Here, the VPD 130H displays the vibration data collected by the AR400 accelerometer data loggers, such as peak-to-peak acceleration and RMS velocity. It allows for the setting of vibration thresholds. When the recorded values exceed these thresholds, the VPD 130H will activate the ALM06WF MP3 alert module through the ET7224 Ethernet I/O module. The ALM06WF MP3 alert module features 6 isolated digital input channels, 1 relay output channel, and an MP3 audio line output, and 8 alarm modes. It includes a built-in micro SD card, T-Flash, for secure data storage. In this case, the alarm receives the digital output signals from the E7224 Ethernet I/O module and emits audible alarms when the vibration values are abnormal, alerting management personnel to take action. Users can also adjust the alarm settings via a mobile device connected to Wi-Fi. Here is a picture of the actual control cabinet with the AR400. You can see the ISN 701 F15 L030 IPE accelerometer cables. In summary, ICP DAS USA has a variety of predictive maintenance solutions utilizing vibration measurement and analysis to determine when it will be most efficient to do the maintenance. This saves time and money due to not doing unnecessary maintenance on a routine, but when the vibration data says it's needed. For a typical manufacturing plant, a reduction in maintenance costs can produce the same financial benefit as an increase in sales. SCADA software like Aviva Edge and Indusoft can be used to create interactive dashboards to monitor vibration on multiple machines and remotely control factory floor equipment. Well, thank you very much for joining our webinar today, and I hope you'll have a fabulous week and a happy Halloween to everyone. Take care and have a great day.